That too many arguments message usually means one tiny thing. Excel thinks you gave a function more inputs than it allows. And the frustrating part is the formula can look perfectly reasonable. The fix is rarely start over. It's almost always a missing parenthesis, an extra comma, or a function being used like another function. In the next few minutes, you'll learn a reliable way to spot the exact breakpoint fast. We'll cover nested ifs, XLOOKUP, and let, because those are the most common places this error hides. You'll also learn why Excel sometimes blames the wrong function, which makes debugging feel random. The goal is simple. You should be able to take any long formula, reduce it to the failing piece, and rebuild it cleanly. Once you have that workflow, the error stops being scary. It becomes a quick checklist item. Next step. First, let's decode what arguments really are. An argument is just a value you pass into a function. For example, if has 3 arguments, a test, a value if true, and a value if false. If you sneak in a 4th item by accident, Excel throws this error. But here's the catch. Excel counts arguments based on separators and parentheses, so one extra comma can create an extra argument even if you didn't intend one. Another common trigger is mixing up function syntax. People sometimes write XLOOKUP like VLOOKUP, or use if like IFS. Also, different regional settings use commas or semicolons. If your Excel expects semicolons and you paste a comma-based formula, Excel can misread the structure and produce argument errors. So the first mindset shift is this. Don't stare at the whole formula. Focus on where Excel thinks an argument begins and ends. Next step. Now for the fastest troubleshooting method. You want to isolate the smallest failing chunk. Start by copying the formula into a safe cell so you can experiment without breaking your sheet. Then work from the inside out. Pick an inner function and replace it with a simple constant like 1 or OK. If the error disappears, the problem is inside that piece. If the error stays, the problem is outside it. Keep shrinking the formula until you find the exact function call that fails. This beats random edits because every step gives you a clear signal. Another trick is to count separators. If a function should have 3 arguments, you should see 2 separators at that level. Extra separators often come from accidental empty arguments, like 2 commas in a row. Once you locate the failing call, fixing it is usually obvious. Next step. Let's talk nested if, because it's the classic place this error shows up. A nested if is just an if inside another if, usually in the value if false position. The most common mistake is adding an extra result, without adding the if to hold it. People try to write 4 outcomes in one if, but if only supports 3 arguments. Another frequent issue is forgetting the last else value. When you leave it blank, you might accidentally create an empty argument with an extra comma. Also, watch out for text quotes. A missing quote can shift where Excel thinks an argument ends. The clean approach is to format your logic in your head as pairs. Condition, result, then a final default. If you have many conditions, it might be time to switch to IFS or a lookup table. Nested if works, but it punishes small syntax mistakes. Next step. Here's a practical nested if cleanup pattern. First, decide your default output. Put it at the very end, so every path returns something. Second, make each if handle one decision. That keeps your parentheses predictable. Third, avoid stuffing calculations directly into the if you can. Calculate them separately, or at least wrap them in a clear function call. When people combine math, text, and conditions in one line, commas and parentheses get messy fast. Also, be careful with optional arguments and other functions inside the if, like text or round. If you accidentally add one more comma inside those, Excel may report too many arguments at the if level, even though the real issue is deeper. The fix is to validate each inner function alone, then rebuild the nested if around known good pieces. Next step. Next, XLOOKUP. It's powerful, but it's also strict about its argument order. XLOOKUP has 3 required arguments: lookup value, lookup array, and return array. Then it has optional ones like if not found, match mode, and search mode. Too many arguments often happens when you accidentally add an extra comma at the end, or you try to pass an option that doesn't exist. Another common mistake is confusing the old VLOOKUP pattern, where the column index is a number. In XLOOKUP, you don't give a column number. You give the actual return range. Also, people sometimes try to provide both a return array and a separate return column index, which becomes an extra argument. The fastest fix is to rewrite XLOOKUP in a minimal form with only the 3 required arguments, then add optional arguments one at a time. Next step. Let's make XLOOKUP debugging even more systematic. Start by confirming the lookup value is a single value, not a range you didn't intend. Then confirm lookup array and return array are the same size. A size mismatch usually triggers a different error, but people fix it by adding extra pieces and end up with too many arguments. Next, decide if you truly need match mode or search mode. Many formulas don't. If you do use them, remember they are positional. If you skip if not found but want match mode, you still need a placeholder for if not found, like empty. Otherwise, Excel shifts your arguments left and interprets them wrongly. That can create confusing argument counts. The clean pattern is include if not found explicitly, then match mode, then search mode. It reads like a sentence, and it's harder to break. Next step. Now, let. Let reduces repetition by naming parts of a formula, but it introduces a new way to get too many arguments. Let expects pairs, name, value, and then one final calculation that uses those names, so the argument count must be even, plus one final result. If you add an extra name without a value, or a value without a name, Excel complains. Another common issue is using a name that conflicts with something else, like a cell reference style name. Keep names simple. Use short, clear labels, like price, QTY, total. Also remember that each name is separated by a comma or semicolon. If you accidentally leave a trailing comma before the final calculation, Excel reads it as another missing argument. The fix is to check the structure. Pair, 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 final expression. Next step. A strong way to build let formulas is to start with the final expression first. Write what you ultimately want, even if the names don't exist yet. Then work upward and define each name one by one. Each time you add a name, test that the formula still evaluates. This prevents you from stacking 5 definitions and then hunting one missing comma. Also, avoid defining too much at once. If a name is only used once, it might not be worth naming. Let is best when it removes repeated calculations or repeated lookups. One more subtle trap. If you paste a let formula from somewhere that uses semicolons, and your Excel uses commas, the name-value boundaries get misread and the argument count goes off. So if you see the error immediately after pasting, check your separators first. Then check that every name has a value. Next step. Let's cover a sneaky source of too many arguments, functions with optional parameters inside bigger formulas. For example, text can take 2 arguments, but people sometimes try to pass a third format piece. Round takes 2 arguments, but sometimes a comma sneaks in when editing. If error takes 2 arguments, but people append a third fallback without realizing it. When these sit inside if, XLOOKUP, or let, Excel might flag the outer function, not the inner one. That's why isolation matters. Test the inner function alone with the same inputs. If it fails, fix its argument count first, then reinsert it. Also watch for accidental array constants using braces, where commas separate columns and semicolons separate rows. Those commas are not function arguments, but they can confuse you when counting. Be deliberate about what each comma is doing. Next step. Another common trigger is mixing separators and parentheses when you copy formulas between systems or sources. Some environments use commas, others use semicolons. If you paste a formula and Excel expects the other separator, it may interpret the entire argument list incorrectly. The result can be too many arguments, even though the logic is fine. The practical fix is simple. Decide what your Excel expects by typing a tiny function like equals if true 10. If Excel autocorrects it or rejects it, you've learned your separator. Then, convert the pasted formula consistently. Also, watch for decimal commas in some locales. A number like 1,5 can be misread as 2 arguments if separators get confused. In those cases, use the correct decimal symbol for your system. These issues feel random, but they're consistent once you know what to check. Next step. Let's wrap the debugging workflow into a checklist you can reuse. Step 1. Identify the function Excel is complaining about, but don't trust it blindly. Step 2. Reduce the formula to a minimal version that still fails. Step 3. Count the expected arguments for that function and compare them to your separators. Step 4. Check for empty arguments created by double separators or trailing separators. Step 5. Validate inner functions independently, especially those with optional parameters. Step 6. Rebuild the full formula by adding one piece at a time and testing as you go. This approach works for nested if, XLOOKUP, let, and basically any complex formula. It's not about memorizing every function. It's about controlling complexity. Once you adopt this, too many arguments becomes a quick repair, not a time sink. Next step. One final improvement is prevention. If you often hit this error, it's usually a sign the formula is doing too much in one line. Consider moving repeated logic into helper cells or into a small lookup table. Use let to name repeated pieces, but keep it readable. Keep nested if chains short, and switch to IFS or a mapping table when conditions grow. For lookups, prefer XLOOKUP with explicit if not found, so your outputs are predictable. And when you edit a long formula, make one change at a time. That single habit prevents 90% of argument count mistakes. If you want, you can even keep a scratch area in your workbook where you test formula fragments before merging them. Small structure choices save big debugging time later. If you found this workflow useful, subscribe for more Excel problem-solving guides. And for a quick check-in, comment with your pick. Do you struggle more with nested if or with XLOOKUP? Subscribe to keep optimizing your workflow and get back more of your time.